Please welcome Matthew to stage 2.
All right, hello everyone. So I'm going to talk a little bit more about the blue team side of things. We're going to talk a little bit about this concept we've been working out called critical infrastructure as code. What we're trying to achieve with this is putting some sort of structure and method to the madness that is configuration management for these control systems. This is an obligatory slide that says this is distribution statement A, approved for public release by the Air Force. So the statement we want to make is that I think we need to reassert control over our control systems by approving their manageability. So safety is property number one of these systems, and safety requires positive control. Now, what does positive control mean? Positive control means you understand what system your state is in now, you understand maybe what state it should be in, and if there's a delta, you can safely control it from one to the desired state. Now, this positive control requires integrity. It requires integrity of your sensors, of your control logic running in your controller, as well as your actuator. And the integrity requires well-managed systems. So are your calibration settings correct on your sensor? Is the logic running on your code correct? And will your actuator faithfully execute any command you send it? And sort of cybersecurity underpins all of these properties. Now, in our view, we think current approaches to configuration management are sort of ad hoc and vendor-specific. Ad hoc in the sense that different people who want to configure the system touch it at different points in time, in different ways, maybe using different software applications. It's also vendor-specific because for a particular device, you may need that vendor's piece of application software, or you actually may need the vendor themselves to come in and do that. So how do, in all these sort of moving parts, how do we sort of structure this process so that it's better? And so what we need to make our management approaches are, one, principled. So we need to think really hard about this problem. What's sort of the correct abstract primitives that we want for configuration management? We want to make it systematic. We want to make it work from sort of commissioning to decommissioning. And for any person who touches that all the way from level 0 up to level 5, and maybe any networking appliance in between, we want it to work for all of that. We also want to make it operator and engineer friendly. So we need our frontline defenders, the people who are there day in and day out, to not be sort of reticent to touch this application software that interacts with the devices. We see sometimes when we go on sites where the actual operator doesn't want to touch the software at all because, in previous instances, that's actually triggered things on the devices. So we need to make it operator friendly. And also, I think sort of configuration management is sort of central to all parts of the cybersecurity problem. So if you know your NIST cybersecurity framework core functions, identify, protect, detect, respond, recover, I think actually configuration management underpins all of those. And so I think to that point, we need to elevate configuration management as a community to be a first-class objective. So this is sort of kind of an outline for the talk here. And so on the one hand side, it's sort of a spectrum of what configuration management might look like in practice. On the one hand, on the left-hand side, we have what's called the infrastructure is the record. And so in short, this means if you actually want to know how your system is configured, it requires you to go log into your devices and to pull configurations, firmware settings, calibration settings directly from the device. Now, the corollary to that, on the opposite end of the spectrum, would be something where we call sort of the generate everything approach. And this is sort of what the infrastructure as code construct is getting towards. And so I'll kind of talk a little bit more about that. But it'd be where you would define everything cleanly and then sort of push it down to the device. So you actually may have two sources of record, right? Ultimately, what's running on the device is always sort of ground truth, but it's good to sort of have a structured way to go about doing that. So on the left-hand side, again, the infrastructure is the record. It sort of starts with people have things in their head, the sysadmin, the network admin, the protection engineer. We kind of all know how we want to configure our system. And then I go out and individually touch each of the devices. And so this, again, goes back to the ad hoc manner. And if I need to change something, like maybe a gateway, or I need to change something like that, I need to actually go touch all these devices individually to update that. So how do we do it where we can centrally define something like that and push it out? And then on the bottom part of the left-hand side is sort of these devices can have configurations saved at different spots. And this could be because vendor application software only points it to different spots. This could be because different people save it to their machines. The vendor comes in and saves it to their laptop versus sort of something on a server is saved. And so we want to kind of get away from this infrastructure as a record and more towards the generate everything. And I'll talk about that part in a few slides. So to take a step back, Why are we here talking to this particular audience? Why are we thinking about this particular problem? Well, the first point is we at the lab, we go out to a lot of sites, we visit with a lot of site owners, and we find that this is just still an open and fairly unsolved problem, especially people who have to deal with sort of heterogeneous systems. They have to care about fire alarms, as well as building management systems, as well as protection relays. That's just a very hard problem to solve, and so we really wanted to think about this. The second point is sort of a little more selfish. We have what's called a hardware-in-the-loop testbed, maybe what the community here typically calls a digital twin testbed. We work in the energy systems group at the lab, and so we build up digital replicas of electric distribution systems. And so this week we might be working on site A, next week we might want to replicate site B, and so we quickly need to manage all the devices that are in hardware like protection relays or genset controllers, as well as change software configurations, maybe to more cleanly replicate network configurations. But we need to do that sort of with a push of a button, as opposed to sort of our manual, pull up the software, change this device over here, et cetera, et cetera. So to that end, we wanted to make it, is there a better systematic code-based approach? So we looked kind of at the IT world, the enterprise world, the cloud service providers to say, what do they do? And sort of this is where this infrastructure as code sort of philosophy came up. To them, infrastructure is sort of things like bare metal servers, virtual machines, containers, software applications, things like that. And so they've kind of coalesced around this thought process called infrastructure as code to manage all those things. So we wanted to take a look and see if that was appropriate for critical infrastructure. And now sort of I have a definition up here of what critical infrastructure for this particular talk, not sort of the definition writ large, but the definition for this talk is sort of any device or machine that can be reached either via an IP network or serial. So anything you need sort of a piece of software generally to configure, that's what I mean by critical infrastructure here. And sort of to tie back to why this particular audience, we wanted to share lessons with you. You guys are at the bleeding edge of things. We maybe wanted to put up a reference architecture and say maybe this is where we could move it to. And then we also want to get your feedback. Are there budding activities that exist out there today that we could leverage? And sort of just to Dale's point about moving the ball forward, that's why we want to talk to this audience. So maybe just quickly some challenges with managing infrastructure. A lot of times it's not managed. We talked to one vendor and they said, I've commissioned a lot of these types of devices. I've never had somebody do backup file or backups of the settings. I've already talked about the heterogeneity. A lot of times as-built are the only source of documentation if they exist. And are they ever updated? We see sometimes they are, sometimes they aren't. The infrastructure can also be fragile. So in this, if you use tools that aren't built by the vendor to interact with the devices, you can see instances where that can cause maybe unwanted device behavior. And I'll talk about one particular instance later. There's many dependencies. I'll talk about that one in a future slide. And then just the general notion of configuration drift, which kind of ties back to the as-builts. But FERC, the Federal Energy Regulatory Committee, they at the end of the year do sort of a roll-up. And they talk about sort of this part of configuration management that was hard, where people would overlook manual steps of the workflow. So how do we think about automating this sort of thing? This is just a snapshot for one particular system that we had to recreate, all the different types of vendor software. Don't worry about reading the actual sort of words on the slide. It's just a notion of there's green buttons, there's red buttons, there's blue buttons, there's all different colors of buttons. There's menus to navigate through. And this is just, if you were an operator and you needed to make a quick, decisive action, it is just really incumbent upon them to know these tools well, and that's just a lot to ask. So to take a step and sort of say, we've kind of gone from problem statement to maybe what does it look like as we try to improve the situation. This isn't quite yet infrastructure as code, although a couple of these properties will sort of enable that. On the left-hand side, I have some properties of the systems that I kind of described that aren't so good, and then on the right-hand side, a desired end state, or what would this look like in sort of a perfect world in our view. So a lot of times, we need another piece of software to configure the device, and I think the previous talk had a good use case for why you need software. If you have a logic engine that's going to generate a binary to upload to a device, you might need that. But generally, can we just remove the need for that application software? So one of the sort of core principles of cybersecurity is to minimize your trusted computing base. And can we do that here by removing those pieces of software? Also, many times you can retrieve or change configurations on the devices for multiple interfaces. In one case, there was Telnet, there was FTP. We could do it via Modbus, and we could also do it by a vendor proprietary protocol. And so that just gets hard to manage all the different ways, and each of them expose a different subset of the settings. And so can we just have a single standardized interface that's well specified? I have up there pointer. Netconf is just an example of sort of a network configuration management protocol where they sort of specify these are the what they call operations that should be used for configuring your device. And so can we think about something like that? A lot of times these devices, you can't retrieve configuration settings securely, so can we just use something like SSH, at least just for the management part? Almost always, these file formats are proprietary or non-human readable. So, if I just get a binary blob, it's not easy for me to inspect really quickly. This gets back to being easy for the end user. So, a couple examples of maybe an interoperable and human readable data format would be something like YAML, yet another markup language, or JSON, JavaScript object notation. I'm not saying these are necessarily perfect, but they're good representative examples of maybe what a file format we'd want to move towards. And I would say for infrastructure as code broadly, people have moved towards those two particularly. And the final point here is that we cannot quickly do some inspection to say what has changed in our files. So if we change it to be human readable, we can then utilize things such as Git or sort of the Unix utility diff to tell what's changed, and Git would give us a log of who changed what, when, maybe a commit message that said why. The ability to roll back and sort of revert to a previously known state. So there's a couple tools that we started to use in our tool belt. So this is kind of the figure I put up before. We're going to focus on the right-hand side now. So sort of the goals and practices of infrastructure as code, and we're kind of down selecting here. But if we look up here, sort of at this level, we want to get towards people specifying their configurations in an explicit manner. So we don't want our sysadmin or our network admin to sort of have the services that they want enabled in their head. We want it to be explicitly listed down in some sort of manner. We then want version control, or the ability to do traceability, auditability. So if you have this sort of network-wide configuration database, something that you can store in Git, for example, just some sort of version control software, you'll be able to do that. And you can also do your rollbacks. Another tenet of infrastructure as code is sort of programmatic accessibility of your configuration files. So can we standardize on some sort of management interface that allows me to expose an API, if you will, and so that we can sort of hit that with any sort of automated script that we might want. Now, I don't think sort of infrastructure as code as a bundle would have all of these things, but I think this is sort of a modular architecture. So can we think about being explicit as sort of one part, sort of the revision control and the configuration database is another part, and then sort of the standardized management interface is a separate part. So I think there are multiple parts of the problem. I think it could be sort of a modular way that we work towards sort of a perfect solution. So here's actually our instance, or our instantiation of what that architecture looks like in our testbed at our laboratory for control system devices. We have at the top there sort of a configuration template database, and then definitions. So we're trying to get these definitions of how we want to configure our devices, and service, maybe for example would be syslog, something that's common across your environment. How can we get these down into human readable plain text? We would then generate that into sort of a database of configuration files. And then we did build a standardized API, and I'm going to go into details of these in follow-on slides. But then ultimately, the point of this slide is sort of to say, what are the devices that we actually configured this way? So we have 3 different protection relays in our lab. And like I said, we're with the Energy Systems group, so this slide sort of has a bent towards the Energy Systems components we were working on. But 3 protection relays, 4 different types of RTUs, remote terminal units. I had a GenSec controller, a load sharing controller, multiple serial to Ethernet converters, and then what's also not listed on here are your general sort of firewall and switch devices. So we managed all of that in sort of this umbrella of what we call infrastructure as code. Now, let's just focus on the top part with the big blue box at the top, and then I'll talk about what it looks like. So what is a configuration workflow that we want to work towards? So I mentioned standardizing templates before. Think about when you have an operating system, you go to provision a new machine, you have a base operating system image, right? So if I have many protection relays, for example, of the same type, I want to have sort of a base image for those protection relays. And so we work towards actually building standardized templates for a lot of these devices. You then go and define your environment. What this means for us, at least, was sort of a really explicit list of here are all the devices inside my environment, and then their corollary IP address. So people can talk about asset inventory and things like that. That was kind of the part that we did there. You'd then define your device and service functionality. So this would be, IP addresses, log locations, protection settings files, things like that that are more specific at the device level. And then ultimately that would generate artifacts. Here, artifacts would mean a configuration file, but perhaps you need sort of a compliance report that says we do these things. And so that's sort of the general configuration workflow. So we looked at sort of the infrastructure as code landscape, and there was a couple of tools for configuration management. There's Ansible, there's Puppet, there's Chef, there's things like that. Your IT administrators would know about these. We selected Ansible as one that was good for our use case. I won't want to endorse Ansible in any way necessarily, but it was good for our use case. It's agentless. You don't install it on all your machines. You just install it in one. It uses SSH to configure things. It's pretty lightweight and has a lot of really nice modules built in. So we used Ansible. So from our general configuration workflow down to the Ansible configuration workflow, you can see it's a pretty good one-to-one map. You define a template, and they have a templating language called Jinja 2. So you just use that where you define sort of your key, and then you hold a variable for your attribute. You then could define your host inventory, your variables, and then your generated config file. And we used YAML for all these, so yet another markup language. So at all points, and I know the text is probably hard for you guys to read, but at all points this is sort of inspectable, it's human readable, and an owner and operator can look at this and understand how their system should be configured. So the next part I want to talk about was that standardized API, or what that interface looks like. So on the bottom half of the slide is actually what the interface is. The top half of the slide just shows these are the devices. This is the Woodward script, for example, and how we interact with them. But the bottom half of the slide is really how we would want to interact with these devices. And sort of when we think abstractly about this problem, here's the minimum set of functions that we want a device to have. So there's upload configuration, there's download configuration, there's what we call fingerprint. You can define sort of a subset of configuration you might want to pull. So for example, if your IT administrator wants to pull things that are related to your network interface, they can go ahead and define a subset. We also want a comparison. So take a reference file that I give you, compare it to your active settings file, and then tell me if those are the same. And if not, tell me what's changed. And then the bottom three kind of get bucketed together with alarms, events, and logs. And so this is just where we're going out and actively querying these devices for that, and they should be able to return it to us in sort of a standardized way. So we kind of said for all our devices, we went up and we wrote, and you'll see on the next slide, ways for us to get all of these from those devices. So we think this is sort of the core set of functions that we need when we want to say we're properly configuring and managing our devices. So here's what we call device translators. So that API doesn't obviously exist for these devices, so we just had to build it. We used just some simple Python scripts and a lot of their open source libraries to interact with them. I'll kind of walk from left to right here across some of the devices and sort of what we found when we tried to do this for them. And I should say, I list the vendors at the top, just in case people were curious. We didn't work with any vendors particularly. We read their manuals, and we understood how their devices worked, and then we built our tools. There was no, I would say, collaboration necessarily that gave us any sort of secret access to any of the features. So for the protection relays, the first one on the left, they expose all of their configuration files via Telnet and FTP. Now, their configuration files are actually text files. This was nice, so we could download that. We could use diffs right off the bat with these protection files, so that was good. They had one sort of proprietary communication protocol, but they had specified the command set we could use on the Telnet command line to interact with the device. But there was no SSH, so not a great secure access mechanism, but at least text files that were human readable. The next class was the remote terminal units. And so we use Selenium, which is sort of a web scraping library built within Python. This one's a little tougher to get sort of really granular details on the configurations, because this is sort of the use case that the person who talked before me, where you actually write, sort of structured text or ladder logic, and it generates a binary file, and you upload it to the remote terminal unit. So you can't actually grab that from the remote terminal unit. It's just the binary blob. So you'd actually need to sort of automate your interactions with the software to get the configuration files. So that one was probably the most difficult piece to work with. Now, Woodward, sort of the GenSet controller and load share controller, they actually had a really interesting way for us to work with their device. They provided a DLL for us. Then it was called automation. So I think it's what they use, but it's a library with methods for actually automatically interacting with the device. So if you wanted to pull settings, change settings, do things like that. The problem is I think we were the first ones to ever use it because it was terribly documented, and when we asked for help, they said, well, we actually haven't even used it ourselves, and so it took us a long time to get back to the right person who actually knew how that was working. Now, obviously, we can do some decompilation and things like that on it, which we did, but the point there is that this existed, but it wasn't readily used. There wasn't good support for it. The other point I want to make is it did have an automatic sort of configuration comparator provided to us. The only problem with it was if the two settings that it compared were true or were the same, it returned true. If they weren't the same, it just returned false, and that was it. It didn't sort of tell you what was different about it. So we would want that to be a little higher fidelity on that. And then maybe most interesting on the last part of this is the serial to Ethernet converters. So we had a CANT to Ethernet as well as an RS-45 to Ethernet. These were actually the devices that were sort of most suitable for an infrastructure as code approach. They provided a REST-like API where I could make calls and return things to me in JSON format. So this was really nice. It actually automatically saved device format or configuration file formats in .ini format, which is another human-readable file format. So we actually found that the serial to Ethernet converters were quite pleasant to work with. So to sort of sum up a little bit of what our findings are, a lot of times interacting with these devices, you're not going to do it in a secure manner, so there's a trade-off. If I'm going to pull configs every day but put my telnet password in plain text every single day, I got to make a trade-off there, and so that's unfortunate. The configuration file parsers can be extremely fragile, so we actually uploaded some files. Ansible, it's much better to use Ansible on Linux than it is on Windows, and so we were using it on Linux, and we had our template, we generated our configuration file, and then when we uploaded it to the device, completely bricked the device. It took us a while to figure out that there was just different line endings from Windows to Unix, and it completely took down the whole device, even though we were changing one configuration file of about 10 on that device. So definitely a red flag. The other one was enabling of the management interfaces exposes additional risk. What this means was the serial to Ethernet converters, which I just got done praising, the JSON interface, when you enable it, it's actually not password protected. So now I enabled this interface, it's really easy to work with, and it has no protection on it. So there's a trade-off there as well. So moving forward, there's some need by vendors to sort of better support better parsers on their devices locally, and I think also to help build the APIs. I think sort of the model Woodward have might be a really nice middle ground where sort of you use the vendor's library that interacts with their own device, and then you can just make calls to their own library. That puts sort of the onus on the vendor to make sure that this is done in sort of a safe and secure manner. The tools that we looked at, they can be used, I think, for sort of the control system world, but they're going to require some modification. So Ansible worked fine, for example. It works really well with Cisco devices, so it was nice to use it for that. But there's going to be they have this concept of a module, and they're going to have some sort of extensions to modules to really support these control system devices. And so sort of the last statement there is the community, the point of this talk also is to get sort of the community to come together and say, what are the functions that we want for configuration management, and what sort of API and tool sets should we build for that? And so to that end, just one of my final slides here is sort of saying, I don't think you're going to go out and buy a configuration or a critical infrastructure as code tool. I think there's multiple parts to this, and I think I've tried to say this in words, but I wanted to make it very clear in sort of a pictorial manner. So you're going to have your tool on the top, which would be like Ansible. You're going to need some sort of standardized interface or maybe configuration management protocol in between, such as netconf, if I talked about, or also OpenFlow. I'm not sure how many of you are familiar with OpenFlow, but this is sort of the protocol or the spec that enables software-defined networking. So, if I have a tool that configures switch rules and flow rules, OpenFlow is the language I speak to the switches. And so that's maybe a nice model for us to think about for this infrastructure as code. And then at every device, we're also going to need sort of an API at the endpoint. So I think there's multiple parts to this problem. And so I'm just trying to lay that out cleanly here, just so somebody doesn't come and sell you a critical infrastructure as code solution and not have all the components. So my final slide here is just to sort of tie back. Defensible and safe systems require positive control. And sort of, we need to think about how we can make this more simplistic for the end users and operators to understand, what state their systems actually are in, so that we can ultimately regain control. So this enables a couple of different things I listed here. One of them is the facilitate configuration control boards. So if you remember sort of the picture of people at the top, if everybody's explicit with their services they want to run or the things they want to configure, it can help with that dialogue. So for example, I'm sitting right there next to our IT administrator configuring switch rules and firewall rules while we're talking about what the needs are of this control system devices. So it was really good for something like that. It also is an easy way to declare network-wide policies. So this would be if I need to configure a syslog server and I need to send that IP address to 10 different devices, how do you define it one place and then push it everywhere, as opposed to logging into all those devices and manually sort of inserting something like that? You can then also do something like automatically generating firewall rules and application whitelist rules. So if I'm being very explicit about this device needs to talk to this device over this protocol in sort of my host inventory work or file, I can then automatically generate the firewall rules for something like that. This was also a good way for us to manage our digital twin environment, so it was nice for that. And as I kind of said before, I hesitate to put IT/OT integration on there, but it did allow us to sit down with folks who have used Ansible before in sort of a more IT environment, and we actually had a really nice workflow between the two parties. So I think thanks. That's all I have. I have a few minutes for questions. I would say also thanks to Joe Cooley, who's my colleague, and this is kind of his idea that we started with, and then we just kind of went with it and worked for it. So with that. Any questions?
All right. Can you use this mic? Oh, hi. Thanks for the great talk. I'm wondering how much of, I'm turning this around from you're looking at the infrastructure, how to bridge this huge gap, right? And you've done great work to try to bridge this gap. There's a lot of differences and, I'm wondering if you can turn this around from the offensive side and how much of your findings and how much of the work that you have done to find these APIs and document them and trying to, find a common language could be used to guide fuzzing and other, exploitation techniques or vulnerability discovery techniques.
Yeah, that's a good point. If we sort of define something like that, you could then automatically build a fuzzer to say, are you compliant with this sort of API? So yeah, it sort of centralizes the things that we need to care about, and centralization could be something somebody could exploit, obviously, too, right? If I write an O-day for one API, then I have it for many. But yeah, I think it could sort of definitely enable us as defenders to better understand our systems, and then to ultimately use tools like that, which can automatically sort of do some sort of static analysis or some sort of fuzzing that would say, this is sort of a safe and secure, part of the system. So that's definitely something that could be looked at.
All right, thanks.
Any other questions? Okay.
Oh, one more.
What do you use for the network-wide configuration database?
Oh, so that would just be we use Git.
Okay.
Yeah, so I can't go back anymore. Yeah, so we just use Git for that. So the revision control system Git. And sort of, I also stated it was network-wide. The nice thing about Git is it's a distributed version control system, right? So one could come back with the argument saying, why would we centralize all configuration files in one spot? Potentially that's a gold mine for somebody to get in and access. You could then maybe have sort of a distributed configuration repository, maybe only installed at substations. But we used Git to directly answer your question.
Okay, thank you.
Yeah, and it just stores flat files, so.
I actually have a question. What do you see? You mentioned that you go into companies and you help them kind of figure their stuff out. Have you seen any resistance on the part of the people that you're actually helping for this sort of approach, or are you having to do all of the consulting work on it?
So they definitely like the approach. Where sort of the pushback we get is on using their existing tools to grab all this data and to sort of transform it into the way that we want it to. It can just be seen as another hurdle or an extra layer of work that's being done. that maybe isn't totally required, or they don't quite see the benefit. So that's sort of the biggest, is that if they have a software application and we need to sort of export configurations from that and sort of do some data manipulation, they can kind of see that as a bit onerous. Would be one thing we see from them. But sort of definitely the storing configurations in a single place, having a methodology and a workflow behind it is something that there's definitely an appetite for that we're seeing. Okay.
All right. Okay. Thank you so much, Matt.
Thanks. Thank you.